Hello, pre-algebra students. Mr. Lawrence here with your flipped lesson. You can read that it says there's a quiz on Thursday. Yeah, so hopefully you're watching this video and you'll be ready for the quiz. All right, something we haven't done in a little bit of time, slope-intercept form. We're going to graph. Remember that when the y is alone, we don't need to make a t-table. When the y is alone, we know the y-intercept, which in this case is 0, -4, right? The -4 coming right from there. And since it's the y-intercept, it means it has to be on the y-axis. Well, every point on the y-axis has an x-coordinate of 0. So this is the point 0, -4. So I'm going to graph 0, -4 right there. Now, to get my other point, I use something called the slope. That's why we call this slope-intercept form. All right, my slope in this problem, they use an m for slope, is 2/3. And remember, that's a rise of 2 and a run of 3. Rise 2, run 3. So what we're going to do is rise 1, 2, run 1, 2, 3. Okay, and from that new point, we can rise 2, run 1, 2, 3. I can do it again if I want. You know, usually 3 points is enough to make a good line, but there we go. All right, so I've got the line. By the way, wouldn't this fraction be the same as 2/3? Wouldn't -2 over -3 be the same as 2/3? It sure would, because the two negatives would cancel out when I simplified. That means I could rise -2 and run -3. And look at that, I'm going to end up on the same line. All right, so now I'm going to go ahead and draw my line. Do I have a line over here? Yeah, I think I do. It's going to go down 2, back 1, 2, 3, and my line is going to go from there to there, just like that. No t-table required. Excuse me. All right, let's look at one more example. This one is not ready to graph because y is not alone. The y is not alone. Remember, the y must be alone. So I ask myself, what's keeping the y from being alone? Well, this 4 attached by subtraction. I'll undo that by adding 4 to both sides. I don't want to add 4 anywhere else. If I do, I'll be adding 8 to one side and only 4 to the other. So these are going to cancel. I'm going to have y equals -3x plus 7. Now, y is alone. I'm in slope-intercept form. The only thing I don't like is usually my slope is a fraction, and that's a -3, so I'm going to put it over 1 and make it a fraction. All right, now I can find my y-intercept, my b, which would be the point 0, 7. And so that'll be 1, 2, 3, 4, 5, 6, 7. Right? And then my slope is going to be -3 over 1. And so I'm going to take him and go down 3, 1, 2, 3, and then right 1, because they're both not negative. Only one of them is. Okay? I could go left 1 and up 1, 2, 3, but I can't make them both negative because they would both cancel out and turn into a positive, and I have a negative number. So I'm going to go down 1, 2, 3, and right 1, and there we go. And now I'm ready to draw my line. There we go. That looks pretty decent. And I might go ahead and just extend it a little bit further this way. And there you go. All right, so make sure you know how to graph and slope-intercept form. Okay, now we're going to do some patterns. And I've got a handy-dandy table made here. Ooh, my numbers are moving on me. And remember, this would go on forever, right? This set of numbers. And I'm going to go searching for the nth term. All right, put my table there. And I'm going to fill in these numbers like so. 1, 2, 3, 4, 5, and then n. And I know I just put those dots in, but they're in the way of my table, so I'll get rid of them. All right, so I'm going to go looking for my first differences. That looks like it's plus 5, plus 5, plus 5, plus 5. And so that'll be something like 5 times n. And I'm going to put those spaces there. And this is my comparison line. Now remember, I plug in the numbers 1, 2, 3, 4, 5 in for n. So here I'm getting 5 times 1, 5 times 2, 5 times 3, 5 times 4, and 5 times 5. And then I'm going to compare. And how do I turn 5 into 2? I add 3. 10 into 7, I add 3. 15 to 12, I add 3. 20 to 17. Oh no, I'm making a mistake, aren't I? Yeah, 5 plus 3 isn't 2. Of course not. Sorry about that, guys. I'd like to tell you I made that mistake on purpose to see if you're paying attention, but that just wouldn't be true. 5 to 2, I'm going to subtract 3. Subtract 3. And subtract 3. Subtract 3. Hopefully those of you that have really been paying attention know what's going on, knew I was making a mistake, and you were going, wait a minute, I don't think Mr. Lawrence is doing this right. Because you know what? Mr. Lawrence knows a lot about math. He doesn't know everything, and he's not perfect. He makes mistakes. Your job is to make sure you can catch my mistakes, help me out when I make one. All right? So, um, if I subtract 3 every time, what do I do to 5n? Well, I subtract 3. So my 5n minus 3. That's my nth term. Now, I would be able to ask you what the 100th term is then. Here, let's do that. Let's add that to our table, and we'll put in 100. Now, all I do is 5 times 100 minus 3, and that'll be 500 minus 3, which will be 497. Okay? You can find any term in the sequence without listing out a whole bunch using this method. All right, here's another example. Bring my pre-made table over. Gonna erase that and gonna put 1, 2, 3, 4, 5, and n. And I'm going to go looking for the first differences, plus 3, plus 5, plus 7, plus 9. And they don't match, so I'm going to go ahead and go down to the second level. And look at that, they're all plus 2. When the second difference matches, then the pattern is something like n squared. Now I'm going to compare it to a pattern I know, or excuse me, I'm going to pretend the answer is n squared, and then I'm going to compare it to the blue ones and see what I might have to do differently. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So how do I turn 1 into 3? Well, I add 2. 4 to 6, I'm adding 2. 9 to 11, I'm adding 2. I'm adding 2. I'm adding 2 every single time. What am I going to do to n squared? I'm going to have n squared, and then I'm going to add 2. And again, I could ask for any term now. Let's say this time I want the, I don't know, the 400th term. Okay, well, I've got to do 400 to the second power plus 2. 4 times 4 is 16, and there's going to be 1, 2, 3, 4 zeros following that, plus 2. So my answer would be 160,002. That would be the 400th term. I don't know about you, but I sure wouldn't want to count all the way up so that I had 400 numbers listed. Get up to 160,002. I'd just rather figure out the formula and then go from there. It's so much easier to do. All right. One last example, and this is the most recent one we've looked at. Okay, get my table in there. Gonna get that out of my way. And I'm going to put 1, 2, 3, 4, 5, and n. And I'll go looking for my first differences. Plus 2, plus 4, plus 8, plus 16. They don't match. But I do notice, look, they're being multiplied by 2. Isn't this times 2? And this is times 2? And this is times 2, right? So that means the pattern is going to be something like 2 to the power n. Yeah, whenever you have them doubling, it's going to be 2 to the power n. If the differences are tripling, it'd be 3 to the power n, etc. So 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. Okay, and then I'm going to compare. How do I turn 2 into 1? I subtract 1. 4 to 3, subtract 1. 8 to 7, subtract 1. 16 to 15, subtract 1. Subtract 1. So my answer is going to be 2 to the power n minus 1. Now, if we do this, go looking for another term, these numbers get really big. Get big really quick. Sorry about that. So I'm just going to do the 10th one. 2 to the 10th minus 1. And now if I'm Michael Said, I know that 2 to the 10th is 1024. At least he could figure it out, which I was very impressed with you, Michael, doing that the other day. So it's going to be 1023. That'll be the 10th term of this sequence. All right, that's your lesson for today. Good luck on the quiz. Mr. Lawrence signing off. Good night, everybody.